Welcome to Google Cloud Talks by DevRel. This is our kind of second edition. We had one last Thursday, and today we're joined by Jez Humble and Dina Portman to talk all about DevOps. And first up, in a couple of minutes, Jez will kick us off and talk about kind of the secrets of high-performing technology organizations. So really looking forward to that. We're going to learn about how to kind of apply technology and drive business value through all sorts of different DevOps approaches. And then we'll have a Q&A after that, followed by a talk by Dina Portman about kind of letting your DevOps data speak and how we can automate software delivery metric collection and visualization. And just as a recap on the series, this is kind of a free digital series, and it serves as an opportunity to connect with Google's technical experts and deepen your awareness and knowledge of a variety of Google Cloud solutions, from ML and AI to serverless and of course DevOps today, and we're going to cover lots and lots of different topics. Each event will begin with kind of this short introduction to a topic and will be followed by a couple of different talks led by these topic experts. So with that out of the way, I want to also kind of let folks know that we have people joining both on YouTube Live as well as in our Hangouts Meet. Feel free to let us know in the various chats and such about where you're joining from, what you'd like to learn more about, questions you might have. And I guess with that, Jez, if you're ready, we can kick it over to you and let you get started.
Perfect. Thanks very much, Ethan. And welcome to all of you this morning, or this afternoon, or this evening, depending on where you are in the world, to the second day of our Google Cloud Talks. So as Ethan said, I'm going to start off by talking about DevOps and our research program that we've been doing for the last 6 years into what makes high-performing teams and how to make your own high-performing teams. And then Dina is going to give detailed guides to how to measure some of the metrics we talk about using a tool that she's built here at Google, which I think is really cool. So I'm looking forward to that as well. So, secrets of high-performing technology organizations. I know we're on a webinar. If it's the morning, you probably want to get tea. So if you want to skip a bunch of my slides, this is the actual bit that you really need to know. First of all, we have a way to measure software delivery performance and the operational performance of your organization, and we know how to get better at that. There's a whole bunch of different ways that you can improve how you're doing at software delivery. Technical practices, process management, leadership, product development. We're going to talk about those and how they work briefly. We're going to talk about culture and how you can measure and change culture. And then finally, we're going to talk about how you actually transform your organization, the best ways to do that for all different kinds and sizes of organizations. So what is DevOps? Well, famously, DevOps has no definition. The people who founded the DevOps movement actually decided there was going to be no formal definition and no formal manifesto. And that means that you're free to make up your own definition. Here at Google Cloud, this is the definition that we have made up: an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. So we're going to start by talking about how you measure software delivery performance. First of all, we have found in our research program the last 6 years that software delivery matters. And we were told for many years that software delivery wasn't actually a competitive advantage. Some of you will remember Harvard Business Review article and the book IT Doesn't Matter by Nicholas Carr, where he basically said it can't create a competitive advantage. And obviously the rise of internet giants has shown that to be false. But we actually were able to measure the impact of high-performing software delivery capability, and we find that elite performers are twice as likely to meet or exceed their organizational performance goals, including both commercial goals such as profitability, productivity, and market share, as well as non-commercial goals that all kinds of organizations, including non-profits and governments, share, such as quality of products or services, operating efficiency, customer satisfaction, and the ability to achieve organizational and mission goals. So the ability to deliver software with speed and stability impacts your organizational goals. Now, the next thing you should be thinking about is, well, how do you measure software delivery capability? And we found in our research program here at DORA a valid and reliable way to do that, which has worked and statistically shown to be valid and reliable over 6 years of data collection and analysis. So there's 5 metrics here, 4 of which apply to all different kinds of software delivery. And it's those 4 that we're going to concentrate on. Lead time, the time it takes to go from a change being committed to version control to having it in production. Deployment frequency, which is how frequently you deploy to production. Your change fail rate, which is when you push a change to production or release a change, what percentage of the time do you have to remediate for some reason? And finally, time to restore, which is when you have some kind of incident or problem, how long does it take you to remediate and restore service? Availability is also important, but it only applies to web software. It doesn't apply to, for example, firmware or apps on your phone, and that's why it's kind of in gray. What we do find is that if you do really well on these other 4 metrics, that's strongly correlated with availability. So you're more likely to have good availability if you do well on the 4 other things. Now, we've been told over the years, or the kind of popular misconception, I should say, is that if you do well at the speed side of this, lead time and deployment frequency, that's going to lead to lower reliability, so higher change fail rates and time to restore. Our research shows that's not true. And if you take one thing away from my 45-minute presentation, it should be this. People who do well at throughput, lead time and deploy frequency, also do well at reliability, which is change fail rate and time to restore. And in fact, in last year's research, we found that our elite performers were able to deploy on demand, and it took them less than a day to get changes live. It also took them less than an hour to restore service, and their change fail rate was in the 0 to 15% bucket. At the other end of the spectrum, low performers were releasing between once a month and once every 6 months. It took them between 1 month and 6 months to get changes live because they're releasing changes in these big batches, in big releases. And when things go wrong, it takes them a really long time to fully restore service, and their change fail rate is pretty high. And we have found this pattern consistently for 6 years, over 30,000 data points from thousands of companies worldwide, that high performers are not trading off speed against stability. They're doing better at speed and stability because the practices that enable you to go fast also enable you to create more reliable services, more stable systems, and indeed higher quality and higher availability as well. So I just want to point out that our research program covers all different sizes of companies, all different types of companies. We've got a good showing from highly regulated companies such as financial services, healthcare, government, insurance, energy, and we have good coverage from very large companies. More than a quarter of our responses come from companies with 10,000 or more employees. And we find that these results that I'm going to tell you about today hold across all different sizes of companies, all different domains. They're universally applicable. We find high-performing teams in really big companies, and we find low-performing teams in small companies and startups. So just because you're big and highly regulated doesn't mean you can't apply this stuff. In fact, this stuff is even more important to be able to apply in large and highly regulated companies, as we'll talk about. So maybe you're not in the elite performing group and you want to get there. How do you do that? Well, that's what we're going to spend the bulk of this 45 minutes talking about. I also want to quickly call out, if you're wondering how you can measure those 4 metrics that I talked about, this is exactly what Dina is going to talk about. So make sure you stay on the line after I'm done to watch Dina talk about how you can measure these 4 metrics in your organization. So high-performing teams, how do we do that? Well, over the last 6 years, we've collected a lot of research on how to get better at software delivery performance. You may not be able to read this slide fully because it's quite small. If you want the full picture, you can go to bit.ly/DORA-BFD, because this is the big and friendly diagram that explains our research program and all the different research we've gathered on how to get better at software delivery performance. And I'm going to do a dive into a selection of these capabilities, but the overall pattern is this. You can see kind of on the right-hand side in the middle, organizational performance, that ability to exceed your commercial and non-commercial goals. That is driven by software delivery performance, which comes just underneath that. Software delivery performance and availability drives organizational performance. How do we get better at software delivery performance? Well, it's that cluster of gray boxes on the left and on the top right, a bunch of lean product development practices, a bunch of lean management practices, a large number of technical practices, and culture and work environment up on the top right. And how do you change culture? Well, by implementing these practices on the left-hand side. So that's the kind of big picture of our research program and what we found. And I'm going to do a bit of a, not necessarily deep dive, but a little bit of an expansion of some of these capabilities. So we'll talk about continuous delivery first, lean management, culture and psychological safety, and autonomous teams. And then we'll end by talking about implementation. One thing to point out is that much of our research is about teams. We don't really talk about individual performance. And the reason for that is it's not individuals who create results, it's teams who deliver results. And the question we should be asking, a lot of people think about, well, how do we hire the high performers? And W. Edwards Deming, who I'll talk about later, says a bad system will beat a good person every time. The question is not how do we get the best people, the question is how do we grow the best people, and how do we create high-performing teams? And really, it's building high-performing teams that is the key to building successful organizations. So continuous delivery, what is that? Fundamentally, it's about making releases boring, being able to push a button and release software to production or into the hands of users on demand at any time. We should be able to make changes, whether those are configuration changes, database changes, networking changes, releasing software, bug fixes, experiments, getting those into production, or if you're building apps or firmware, into the hands of users safely, quickly, and sustainably. My favorite metric for continuous delivery is how many person hours outside of normal business hours do you spend releasing software? And the answer to that should be 0, because you should be able to push a button and release software without any user impact at any time. And that should be a low risk, repeatable process. That's the goal. There are a lot of things that go into continuous delivery. You can see there's a whole bunch of technical practices, and I'm only going to cover a few of these. Everything from how you do software development, developing on trunk instead of on long-lived feature branches, continuous integration, the practice of regularly integrating code into a shared trunk and then running tests and then fixing problems that you find straight away, deployment automation, and indeed continuous testing and automated testing. I'm going to talk about loosely coupled architecture a bit. That's important. Monitoring and observability. Monitoring and observability. I'm not going to talk about in detail, but that's important. Database change management, a whole bunch of things. These things all impact your ability to make changes quickly, reliably, safely at any time. And that in turn has a bunch of different impacts, not just on software delivery performance, but also on your culture. It also results in teams that are less likely to be burnt out. It reduces deployment pain, and it reduces rework, which means higher quality, measured in terms of the amount of time your team is spending doing rework rather than building new features. And software delivery performance and organizational culture in turn drive organizational performance. A lot of these things are focused, a lot of these capabilities, these technical practices are focused on building quality in. W. Edwards Deming, one of the founders of the total quality movement, which was part of the lean revolution in Japanese manufacturing, had this to say about quality. He says, cease dependence on mass inspection to achieve quality, improve the process and build quality into the product in the first place. And that means that everyone is responsible for quality, including developers. And this is quality understood very broadly, not just are there bugs, but is the software reliable? Will it scale? Is it secure? Does it actually help customers achieve the outcomes they want to achieve? These are all pieces of what it means to build high quality software. And the key thing is, if that's not built into the software in the first place, it's much, much harder to fix later. If you build software that's not secure, you can't have the InfoSec fairies come and wave their magic wand and fix that downstream. If you don't build software that's scalable and reliable, the DevOps fairies won't come and fix that for you. You can't wave the magic wand and have the DevOps unicorn ride in with a rainbow and fix that problem downstream. Developers are responsible for building secure, reliable, scalable software and responsible for making sure that that software actually delivers the outcomes that the business is expecting it to deliver, which is really hard. And most organizations aren't set up in a way to enable developers to get the feedback they need to make that happen. So this is hard, it's difficult, it takes a long time. And so I don't want to underestimate the extent to which this is a hard and often long journey, but this is fundamentally what a lot of these practices is about. This is sometimes called shifting left. So you take things that are typically downstream, like testing or security analysis or performance analysis, and you shift those into the software delivery lifecycle upstream at dev time. And when you build a feature, you also make sure that feature is secure and stable and reliable and performant and so forth. In order to do that, you'll need to build something called a deployment pipeline, which is the key pattern of continuous delivery. And the idea is that everything that you need to reproduce your entire system, including database changes and infrastructure configuration, is all in version control. Anytime you make a change to any of those things in version control, that's going to trigger building your software and running automated tests, which should be able to complete in tens of seconds or minutes at the worst. Those aren't a comprehensive set of tests, but we get some idea if the software is releasable. If there's any problem, we fix it straight away. Once we have a build that passes the basic commit tests, we're going to run more comprehensive tests against it that might take tens of minutes or hours. We're going to run those in parallel on a big grid and get much more comprehensive feedback. Again, if that feedback shows there's a problem, we fix it straight away. And then once we have builds that pass all the automated tests, they're available on demand for things like exploratory testing and usability testing, and then more computationally expensive validations such as performance testing and security testing and so forth. And then we can also on demand release software to staging environments, to production, to canary loads and so forth, and get feedback on whether what we did actually created the business outcomes that we expected. So the idea is that every change results in a commit that is releasable, and we should try and get those commits as far as possible to production and find problems as quickly as possible and create fast feedback loops so that developers can quickly get feedback if they did something that impacted the wider system in a way they didn't expect. So we shouldn't have to wait weeks or months to get feedback from QA or from performance testing or from security testing. Okay, somebody actually muted me from the Hangout, which is a new one. That's pretty cool. So please don't mute me because I'm the one that's talking, and then the presentation won't be very good. So that's an overview of the deployment pipeline. You may feel like that. We've all felt like muting me, I know. Thanks, Dave. So a key thing that we're trying to achieve with the deployment pipeline is shortening lead time. So some people create these deployment pipelines. They're very long and complex. And you really don't want to do that. What we're trying to do, one of the things we're optimizing for, one of the key metrics is short lead time. So we want to make the deployment pipeline as short as possible and as wide as possible. So we want to parallelize these activities as much as possible, which is why the continuous testing comes into play, for example. Lead time is important because that's what gives you feedback loops. This is a great question from an early book in the lean software movement by Mary and Tom Poppendick, where they ask, how long would it take? Yeah, Chinmay Pardikar, Kripya nahi mute karo. So lead time is how long it takes you to get changes to production. And the question you need to be asking is, how long would it take your organization to deploy? Okay, I'm really sorry. Chinmay Pardikar keeps muting me. If someone could please, Chinmay, I think we're going to have you join the live stream if that's okay. Lead time. Lead time is about how long it takes your organization to deploy a change that involves just one single line of code. Do you do this on a repeatable, reliable basis? So if it's hard for you to actually measure lead time, and again, Dina is going to talk about this later, this is the question to ask yourself, to think about your lead time, how long it's going to take your organization to deploy change that involves just one single line of code, and can you do that repeatably and reliably? This is really important, not just in terms of getting feedback, but in terms of actually building secure systems and secure organizations. So a question that is particularly important in an enterprise context is, what do you do when you discover a vulnerability in your system? If there's a CVE released about vulnerability, how long would it take you to patch all your production systems in order to be able to update them, to patch them all with the fix for that CVE? So this is a situation where time to restore and lead time are super important. This was, for example, really important in the Equifax breach. Equifax breach was due to Apache structs having a vulnerability. That vulnerability was fixed on March the 6th, but it took Equifax a really long time to actually find and fix all those vulnerable systems. And by the time they did that, they were already being attacked. So this kind of situation is where lead time and good configuration management and all the things we talk about in continuous delivery actually become really important. So people say, well, continuous delivery, is that really applicable in mission critical systems, in regulated industries? And the answer is, it's even more important in those situations. These are the kind of practices that help you in this situation where actually security and reliability are really critical. How do we build security in? Well, we did some research on this, and we find that elite performers build security in and conduct security reviews and complete changes in days, so as opposed to weeks or months. So elite performers are able to build security in and do security reviews very quickly, and indeed find and fix those problems really quickly as well. Whereas low performers can take weeks to conduct security reviews and complete changes. And there's a bit of a shift here from security teams finding problems downstream and fixing them to security teams helping development teams do the right thing. So we want to make it easy for development teams to consume pre-approved libraries and packages and tool chains and have secure processes. So InfoSec becomes less about inspecting and more about helping teams build security in and do the right job. And this is also something we find with things like change management. We don't have change advisory boards actually inspect changes anymore. We help development teams or delivery teams implement continuous delivery and build quality in rather than inspecting changes. So it becomes more about governance rather than actual inspections. So, sorry, Q&A. I'm actually going to run Q&A through. I'm actually going to run Q&A through slides. So this is the link for Q&A, and I'll have some time for questions at the end. Thanks, Mandy. I totally forgot to do that. The next thing I want to talk about is architectural outcomes. So architecture is super important in terms of being able to implement continuous delivery. And we found that there's 5 things in particular that you need to be asking about whether you're implementing architecture well. Number 1, can my team make large-scale changes to the design of the system without the permission of someone outside the team or depending on other teams? Number 2, can my team complete its work without needing fine-grained communication and coordination with people outside the team? 3, can my team deploy and release its product or service on demand independently of other services the product or service depends on? Number 4, can my team do most of its testing on demand without requiring an integrated test environment? And finally, can my team perform deployments during normal business hours with negligible downtime, which is the piece that I talked about earlier. And it's important to note, you could implement the latest WYSI microservices architecture on Kubernetes and fail to achieve these outcomes. In which case, the question is, did you actually do any good? Equally, you could have a mainframe system and implement these capabilities and achieve these outcomes. So it's not just about tools. Obviously I work for Google Cloud. We produce things like Kubernetes that are awesome and they're really good, but it's not just about implementing the tools, it's about achieving the outcomes. So as you're implementing your tools and you're doing your technology transformation, you've got to ask about the outcomes you're achieving and whether your tool implementation is actually helping you achieve these outcomes. That's super important. Cloud is really important as well. We looked at cloud and cloud implementation as part of our research program, and we find that elite performers are 24 times more likely to have done a good job of cloud implementation compared to low performers. But what does it mean to do a good job of cloud implementation? Well, the US government has an agency called NIST, the National Institute of Standards and Technology, and they produce a whole bunch of really actually useful documents on how to do technology implementation, including a bunch of regulations that you have to follow if you're building federal government information systems. One of the shortest documents they produced is a definition of cloud, 5 essential characteristics of cloud computing. And they define these 5 characteristics that you can see on the right, which are what it means to actually have a cloud. Number 1 is on-demand self-service. Can people self-service the cloud resources they need on demand rather than having to raise tickets or send emails and so forth? Do users have network access to the cloud resources from all kinds of different devices and all kinds of networks? Can I access those cloud resources on my own devices, on tablets, on phones, as well as my corporate desktop? Do we have resource pooling? Are there a large number of virtual devices that are sharing a smaller number of physical devices? Number 4, rapid elasticity, which is the illusion of infinite resources. Can I self-service as many resources as I need on demand without running into hardware limitations? And finally, measured service. Do I only get charged for what I actually use, which is the key economic driver of the adoption of cloud? And what we find is that out of the people who said they were using cloud or had implemented cloud, only 29% of respondents actually met all these 5 characteristics. It's really common in an enterprise situation for organizations to buy a cloud, but if developers want a test environment, they still have to raise a ticket in ServiceNow and wait days or weeks for that test environment to be provisioned. And then you don't actually have a cloud. You don't have on-demand self-service, and there's no impact on outcomes for developers. And so we can't achieve the improved agility that we expect from a cloud adoption. So it's really important to actually look at these outcomes again and see if your cloud adoption is achieving these outcomes. And again, if you are actually doing it right, it's hugely impactful. 24 times is a really big number. So, I mean, because of the correlation, what it means is if you've implemented these characteristics, you're 24 times more likely to be in the elite performing group. So really important, but you've got to do it right. So that's my brief overview of some of the technical characteristics. I want to talk about some of the management stuff now and some of the culture stuff. We find that lean management practices and lean product development practices are really important as well. Lean product development practices come from the lean startup movement and a bunch of people who've been talking about effective digital product development practices over many years. Things like working in small batches, turning big features into small chunks of work that can be completed and deliver user value in the space of a few days. Making the flow of work visible so everyone can see the flow of work from coming up with ideas to designing features to building and deploying them. Can everyone see that flow of work through the organization? Are we actually gathering and implementing customer feedback as part of the delivery process? Are we doing user experience research as part of development and building what we learn from users into our software? And then finally, team experimentation. Do teams actually have the authority and ability and resources to experiment with new ideas and to experiment with new ways of working? Very common agile implementation in enterprises is to tell all the development teams to follow the exact agile process as it's written on this document. And guess what? That's not agile. Agile is about enabling teams to experiment with new ideas and change their process in response to what they find in an empirical way, not about telling everyone to follow the rigidly defined agile process. So we find that lean product development practices impact software delivery performance. They also drive directly organizational performance, and they contribute to better culture. Lean management practices, these come from lean manufacturing ideas like limiting work in process, visual management, so you can see the quality of what you're building on visual displays, getting feedback from production and using that to make business decisions, and using a lightweight change approval process like peer review instead of a heavyweight external approval process like change advisory boards. These things together all impact organizational culture. They all contribute to increased software delivery performance, and they result in less burned out teams. One interesting thing we found from our research, by the way, is that you have to do all of these things. Limiting work in process, visual management, feedback from production, these things all go together. If you just limit work in process on its own, it doesn't work. You have to do all of those things together. Someone just asked, what's the definition of elite performer? The answer to that is way back at the beginning of this presentation, right here. Here's a table. This is from the 2019 State of DevOps report. You can go and download that by going to cloud.google.com/DevOps. All 6 years of the State of DevOps report are there at the bottom of the page. You can download those reports. In that report in every report is a table showing how we broke down the responses into these different groups using statistical analysis, using cluster analysis. So that's our definition of elite performers based on cluster analysis of the responses to the research program. So, lean management and product development practices, these drive culture. We talked about how these technical practices drive culture. What is culture and how do we measure culture? Well, we use this model from a sociologist called Ron Westrom. So Ron Westrom was a sociologist looking at safety outcomes in healthcare and aviation and nuclear power. So these are safety critical organizations. And he found that you could model culture in the way that's shown in this table, and that was a really good way to predict how those organizations dealt with safety and how safety outcomes were characterized in those organizations. And so in this typology, he divides organizations up into pathological, bureaucratic, and generative. And you can probably see easily what kind of organization you're working in right now. So in pathological organizations, there's low cooperation, messengers are shot, responsibilities are shirked, and so forth. In generative or performance or mission-oriented organizations, there's high cooperation, messengers are trained, risks are shared, and so forth. So 6 different axes here. Firstly, cooperation, the extent to which we actually work together across different parts of the organization. Secondly, how do we deal with bad news? Are messengers shot? Are messengers ignored? Or do we actually train people to bring us bad news so that we can act on it as soon as possible, rather than not telling anyone, especially not management, because we don't want them to know that there's any problems. And then the problems that we have become more and more serious and catastrophic, and then they become really very serious, and we get cascading failures and disasters. Thirdly, how do we deal with responsibilities? Are responsibilities avoided because we know that if something goes wrong, we'll get into trouble? Are they defined narrowly so that when something goes wrong, we know whose fault it is and we can blame them? Or do we share risks because we know we succeed and fail as a team? How do we deal with bridging between different parts of the organization? Is it discouraged? Don't go and talk to the product people or the business. We don't want them to know what we're doing. Or do we encourage bridging between departments? And then finally, 2 things that are really 2 sides of the same coin. How do we deal with failure, and how do we deal with novelty? If failure leads to scapegoating and punishment, no one is ever going to try anything new, because in a situation where failure leads to scapegoating, what happens is people are afraid of trying new things because new things are likely to go wrong, and that will lead to failure, and then they'll be punished. In organizations where we accept that we're working in complex systems and where things will inevitably go wrong, because in complex systems, failure is inevitable. When something goes wrong, we don't ask whose fault is it? Oh, it was Jez's fault, let's fire Jez, because we know that if we hire someone into Jez's position it's very likely something similar will happen and Jez will make the same mistake. Instead, we should be asking, how can we get Jez better information so that next time this happens, Jez will be able to make better decisions. And if he does something bad, it won't lead to a catastrophic problem. We'll have a system that finds that and fixes it early so that these problems don't become catastrophic cascading failures. So when there's a failure, asking who is the person who contributed to that failure should be the start of the inquiry. And then we should be asking, how do we get people better information? How do we help people make better decisions? How do we improve the system so that failures can be detected and we can actually get people better information and prevent disasters? And in a situation, in a system, in an organization where failure leads to inquiry and people aren't punished for failures, people are more likely to feel comfortable taking risks and implementing new ideas. This has actually been validated by some research that Google did, which is quite well known. Project Aristotle within Google was designed to find out how to build high-performing teams within Google. And what was found was it wasn't about hiring from top business schools or top technology schools and then getting rid of all the senior leadership or the managers. What we actually found was that the most important thing was that team members felt safe to take risks and be vulnerable in front of each other. That was actually the most important thing. And then dependability. And in our research, we found that psychological safety and dependability were actually the same thing that Westrom is talking about in his model here. So Google's research actually reflects what we found in our DORA research program, that psychological safety is really important. We actually do disaster recovery testing within Google. We have a program called the DIRT program, Disaster Recovery Testing Program, where we build these quite complex scenarios that we execute over 72 hours or so once every year. For a long time, Kripa Krishnan was in charge of the team that designed and executed those disaster recovery testing exercises, where they would actually do things like switching off the connection between Mountain View campus and the rest of the world and powering off data centers to execute scenarios like aliens invading Silicon Valley, for example. So these are real exercises that do real damage to our infrastructure, and teams have to maintain service in the face of these problems. And we find out all kinds of crazy things about our organization. Like we find out, for example, that the conference bridges don't have enough capacity for all the people dialing in, or that people don't know how to requisition emergency diesel for the data centers and stuff like that. What Kripa Krishnan said about these disaster recovery testing exercises is this: for DIRT-style events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. In our research last year, we found that only 40% of respondents to our survey perform disaster recovery testing at least annually on production infrastructure. So that is something that you should be thinking about, particularly if you're running in a safety critical or regulated industry. A key piece in actually being able to scale your organization and implement these ideas is making sure that you build autonomous teams. And we found that autonomy directly drives software delivery performance. Autonomy also creates teams where people can trust each other better and where people feel more confident speaking up. And those two things also drive organizational culture directly. So autonomy is really important. Being able to build autonomous teams where you set the objectives for the team, but the teams have autonomy to decide how to actually achieve those objectives and the processes they use and so forth. That's really important to achieving some of these goals too. That also links up really nicely with some of the architectural stuff that I talked about earlier. If you recall, when I talked about architecture, I mentioned some things that are not just about technical enterprise architecture, but also about team architecture, the ability of teams to make large-scale changes to the design of their systems without the permission of someone outside the team or depending on other teams, to complete its work without needing fine-grained communication and coordination with other teams. That's about autonomy, which is super important. So architecture and organizational structure are strongly linked, and that's important. I'm just going to end by saying a few words about implementing some of these ideas, we looked at strategies that organizations use for transformation. And what we find is that elite performers are more likely to use things like communities of practice or grassroots transformation implementation strategies. Just to summarize this, what we find is that high performers favor strategies that create community structures at both low and high levels of the organization, likely making them more sustainable and resilient to reorgs and product changes. The top two strategies employed are communities of practice and grassroots, followed by proof of concept as a template, which means trying ideas out on a small set of teams and then taking what works and spreading it, and taking the lessons learned on what doesn't work and spreading that throughout the organization, and using a proof of concept as a seed. So again, autonomy is really important to enable this, because you've got to be able to have teams in your organization experimenting and building communities of practice organically. You can't just mandate that everyone implements DevOps and continuous delivery by following this recipe. That doesn't work, which is hard, and it takes time. And anything organic like this relies on cultural stuff. So there's an important thing to bear in mind there, that implementing the practices drives culture, but you also need some level of culture in order to be able to implement these in an organic way. And that just brings us to the last thing, which is you've got to have effective leadership for this to work. We found that transformational leadership, which is leadership that provides intellectual stimulation, that provides inspirational communication, that's supportive of teams, that provides personal recognition, that has a good vision. This is critical in order to be able to implement a bunch of these practices. And we actually found that effective leadership drives the implementation of a number of these capabilities that we talked about. Just one example of communities of practice from Google that I think is really interesting is unit testing wasn't always a big deal at Google, and it wasn't very widespread. There's a really nice story in this article by Martin Fowler, written by an ex-Googler called Mike Bland, which talks about how Google implemented unit testing. And it was done using a community of practice, a testing grouplet, a team of Google developers who basically built a program to promote unit testing and adoption throughout Google. It was a group of volunteers with not very much funding and no direct authority that relied on persuasion and innovation. They built this program called Testing on the Toilet, where they had a monthly newsletter that was printed out and put on the back of every toilet cubicle in every campus in Google. And that program actually persists to this day. There's testing on the toilet today at Google. If you go to a Google office and go to a toilet cubicle, you can read about testing. There's no way for you to escape thinking about testing. And that's just one of the many ways that the testing grouplet found to help build the culture of testing at Google. So that's a great example of community of practice. So just to recap, we can measure software delivery and operational performance. We know how to get better at it. If you want to get better, you've got to implement technical practices, effective management and process improvement, effective product development. That's done by effective leadership and building communities of practice within your organization. All these things drive culture. Culture directly drives organizational and software delivery performance. And that makes your organization better. This stuff is important, it matters, and we know how you get better at it. Just today, there's an article that was published by the chief architect at HSBC, which is a customer of Google Cloud, talking about how they're implementing some of these practices at HSBC. They have this saying, double, half, and quarter. Their goal is to double the frequency of releases, half the number of low impact incidents, and quarter the number of high impact incidents every year. So that's how they use the four key metrics I talked about earlier, and set targets for those and leave it up to the teams to work out how to do better at that. So you can go and read this blog post by HSBC's chief architects, which talks about how they're using the research that I talked about today to drive improvement in their technology organization. So we just have a couple of minutes for questions. If you have questions, there's a link at the top of the slides here. For more on this stuff, you can go to cloud.google.com/DevOps. There is a quick check there where you can find out how you're doing on those four key metrics. There's links to articles about all the different capabilities that I talked about today, our research program, the last 6 years of the State of DevOps report. There's more events like this. If you go to this URL, events.withgoogle.com/google-cloud-talks. I can't see any more questions other than the one I've answered. Yifeng, are there any more questions coming in on the chat? Oh, sorry, the link only works for Googlers. And I can't hear you, Yifeng. No, I can hear you.
Okay, sorry, I think that was a different user, but we posted a public accessible link in the chat if you want to swing over there. Yeah, Dave just dropped it in. But I'll give you some of the questions here. One of the top questions here, well, the only one with a vote, I guess, is what do you mean by communities of practice? How are these set up?
Yeah, great question. That's kind of why I posted this link to give you an example of what a community of practice looks like. There's a really good book about communities of practice. Let me just quickly get the title, the author of that. It's called Communities of Practice by Emily Weber. Building Successful Communities of Practice by Emily Weber is a good book on that, and Emily Weber has some presentations about building communities of practice. But it's basically organic structures within the organization where people who are interested in a common practice get together and talk about it. And this is why it's so important for your organization to provide resources for things like internal meetups, internal conferences. A lot of organizations run internal DevOps days. And just for people who are interested in a topic to have the time and resources to just get together and discuss it. You can do it over email groups, on group chat links. You can set up chat rooms to discuss a particular topic, but just giving the people the opportunity to find ways to get better and some resources to help implement these ideas. That's what a community of practice is. Go and read this article that I just linked. It's a direct link to a section within this really huge article where it talks about the testing grouplet within Google. That's a great example of a community of practice.
Awesome. Thanks for sharing that, Jez. And if you want to turn off your Ask a Question link, it'll let your slides be a little bit bigger on the presentation as well.
Oh, thank you very much. I will do that.
Meanwhile, another question coming in is how will startups adopt this model since resources are scarce?
Well, that's a great question, and actually a pretty wide question.
Yeah.
We're kind of short of time, so I'll give you a short answer, which is that startups have the advantage that everyone knows everyone else, and you can just talk to each other. And so a lot of startups hire for the skills they actually need to solve the problem at hand. And so ideally you'll hire people who have the skills that you need, and you can just talk to each other as part of your regular meetings. And those meetings are, if you've got a 10, 20, 30 person startup, you're holding regular meetings where you can just talk about these things and solve them in real time and try things out because you're small.
Awesome.
As organizations grow, that becomes much more difficult. And that's when things like this become more important. And when you can't hire for just the skills you need because you're going to last for a long time and those skills are going to go out of date, and you need to focus on helping your people build the skills they need and evolve their skills to solve the problems at hand and actually invest in capability development.
Absolutely. And a question from a gentleman named Tibor. How would you implement strategies for resilience in the culture in case of presence of malicious actors? Interesting.
Sorry, can you repeat the question?
How would you implement the strategies for resilience in the culture in case of presence of malicious actors?
Yeah, so again, in the presence of malicious actors, these things that I'm talking about become even more important. So if we go and look again at culture, one of the things we're trying to do with continuous delivery is build feedback loops. And one of the things we're trying to do with culture is increase information flow. When Westrom was talking about this stuff, he talked about information flow. So every organization has bad actors. And the question is, how quickly can you find out about them? And in an organization with an open culture and with fast feedback loops and where you're building security in, it's actually much easier to find when people are being bad actors and handle that early. What you find in cultures where it's very secret and it's very hierarchical is that bad actors actually flourish in those kinds of organizations. So building an open culture and a culture of fast feedback loops and building security testing in, that's actually even more important in organizations which are safety critical and highly regulated, where bad actors can have outsized impacts.
Fantastic. Thanks so much, Jez, and for presenting
Thank
on
you.
this really, really important topic and covering it in such a thorough manner. I think at this time we'll start transitioning over to Dina's presentation. Dina, are you on?
Yes.
Okay.
Yes, I am.
Cool. So if you want to take over presenting, just start sharing your screen, and that should bring us over and have you pop up. And did you, by any chance, tweak your slides to allow the Q&A to be accessible publicly? Alternatively, happy to just continue using this Q&A. I can moderate and just read it off to you at the end, if that's easier as well. We can, and we can also see your code, your console on the right-hand side of the screen as well. Okay. So it's always a relief, right? Of just like, oh, okay, she didn't mean to.
And I figured we would just use the same
Great.
Q&A link, so I kind of just stuck it on my
Thanks.
screen down there. Yeah. Okay. I'm Dina. It's really nice to talk to you all today. I'm going to talk to you about automating your metric collection around your DevOps and visualization. And so the main tool that we are going to be using is Cloud Build. If you're not familiar with Cloud Build, it is a service that executes your builds on the Google Cloud platform. It allows you to do all sorts of things. It's super flexible. You can build and deploy your applications. You can run tests. You can run end-to-end tests. You can run custom bash scripts. You can read from custom Docker files, Docker images. And there's, it's very flexible and useful. And one of the really cool built-in things that it does is if you've enabled the PubSub API, Cloud Build will take the entire data from every build event and it will send it to PubSub. And if you're not familiar with PubSub, it is an asynchronous messaging service. So you send it messages about events, and then there will be a subscriber that will do something with that data. And this is what the anatomy of a Cloud Build PubSub message looks like. In the attributes, we have the build ID, we have the status, we have the data, and we have the subscription. The data is base64 encoded. And for Cloud Build messages, this will actually be JSON when you decode it. And it will have all of the information about the build. So it'll have the start time, it'll have the finish time, it'll have the steps that the build took. So, if you have one build that's just running test pipelines, all that data will be in there. If you have a build that is being triggered off of a GitHub commit or push, the actual SHA from that GitHub commit will be in this JSON data. So it's everything that Cloud Build knows about the event. It's just sending it to PubSub, and it's there for us to use. Which brings us to our demo. So if you want to, you can feel free to follow along. I'm going to show you how quick it is to set up and start getting information about your builds and deployments. Okay, so we're going to create a project. Let's see if this is still available. And the reason why I am creating a new project is because I just want to show you, I don't have anything pre-configured. I don't have anything set up. I don't have permissions set up. This is completely from scratch. So any issues that I run into would be issues that you might run into as well. Cool.
Can you please zoom in on your code?
Yes. Ooh, how do I put it back to the top? Okay, well, it reset there. Is this big enough? Yeah, yeah. Okay, so the thing that I just did that we kind of, cleared out my screen when I resized it, was I just created a new project. So that's the G-Cloud projects create. The next thing that we need to do is we need to enable billing. And the reason why we need to do that is because some of the tools that we're using require billing. And if you're using the free trial billing, if you want to follow along, you need to upgrade it because the free trial billing, some of the functionality just doesn't work with these tools. And so if you have to upgrade it, it'll be down here. It'll be a little like blue button that says upgrade. Okay. Okay, so we have this new project. There's nothing in it, brand new. You saw me create it. I feel like a magician. There's nothing in the box. Okay, I've already cloned this project. I'm already in this repo. So let's just take a peek at it. We have a Docker file, README, a cloud build YAML, and some other code there. So next thing we're going to do is we are going to turn on these APIs. GoogleAPIs.com. Oh, cloud config list. Let's make sure I'm in the right project. No, cloud config set project fun with metrics. Now I'm in the project, and now I can turn on my APIs. It went too fast, so I knew I knew I wasn't in the right one. Okay, so now we have PubSub. Let's take a look at it. Voila, there it is. Nothing in there. We're going to turn on Cloud Build. And the thing that should happen when you turn on the Cloud Build API is it should create automatically a topic in PubSub called Cloud Builds. Sometimes it doesn't. And the official instructions in the docs is if it doesn't do it, you can turn the Cloud Build API off and on again. We'll see, and we will hope it's there. If it's not, we're just going to create it ourselves because it's faster and easier than, alas. Okay, so it should be called Cloud Builds. Create topic. Okay, so now we have our topic. It's empty, nothing going on there. And we are going to just turn on a few more APIs that we're going to need. We're going to need a little bit. And so I'm turning on the Cloud Run API because the Cloud Build that we're going to be using builds and deploys an application on Cloud Run. And okay, there we go. Great, we have our APIs, one more API, enable BigQuery.googleapis.com. Cool. Okay, so we're going to create a PubSub subscription because right now we have our nice PubSub topic, but there's nothing looking at it. So if we sent data there, it would just die. It would just, languish and eventually disappear. Okay, let's look at our subscription. There it is. We're not actually going to use this subscription. This is really just for testing. This is just for testing, and it's so like as we go through and we check to see that the communication between these two things are working before we build more stuff, down the pipeline. We want to make sure those are talking and connecting together. Okay, so before we build, let's take a quick look at our Cloud Build. Okay, so here are the steps in our Cloud Build. It's going to build the image from our Docker file. It's going to push it to the container registry, and then it's going to deploy the image to Cloud Run. So we know that when this Cloud Build builds, that will be a successful deployment. We're going to take a quick peek at this Docker file. And I am going to edit this very quickly to use the Alpine image of the Golang because it is smaller and quicker, and we want this to go super quick. Okay, so now we get to the fun part. Now we have everything set up. We are going to build a cloud build. So as the cloud build happens, there are multiple stages, and it actually sends an event to PubSub for each of the stages. And so one of them will say queued, one of them will say working, and then there'll be like a success or a failure. So even though this is still running, we can already take a peek here and see what's coming in. Cool. So we can see the status here was queued. Down here, we can see the status is working. And this is very exciting because right now we already have some information about our DevOps. We know that somebody or some system tried to attempt a build today, at this timestamp. Failure, very exciting. Because now when we pull, we can see, let's do this a couple of times, we can see a failure status. So right away we know not all of our deployments are successful, some of them are failures. And that is very important if we want to know things like failure rate. So the reason why this failed is because some permissions errors. So let's fix those real quick. And what we need first here, we just need this project num. And then we are going to make sure that cloud build can execute and do cloud run admin tasks. We also want to make sure that cloud build can act as a service account user. Okay, so let's try building it again. And if we fixed all the permissions, we should get a success. Oops. Subscriptions, let's take a peek. See the data coming in, flowing in. Yeah, just like, in just a few minutes, we already have this pipeline where this data about our DevOps is just funneling in with very little configuration on our part. In here, we can see there's a new build that's been queued. It is running through the build. You can see that it's working. Awesome. So when we look at, so there's some really nice things that the PubSub UI does. When we looked at this data before, when we looked at the anatomy of a PubSub message, this was all base 64 encoded, and so we couldn't really understand what it was. It just looked like gibberish. The PubSub UI very helpfully decodes it and kind of starts to give us information. So one of the important things to note here is that these JSON keys in the body of the message, they're not the same. They won't be the same as your, so for instance, like this one has a body finish time and these two are null. And this one has, step images. So obviously when it's like queued, it wouldn't have that information yet. And so when we're talking about building these data pipelines, we want to make sure that we do our data transformation really quite a bit further downstream, because if we had the next step in our pipeline be that we were going to start parsing this JSON and pulling out, this SHA or, different timestamps or the build steps, then what we're doing is we're losing the information about these events that didn't have that information in it. So that is very important to remember. And let's take a look at this. This UI is great, but it can be kind of difficult to understand. It's just so cluttered, and it can be kind of difficult to understand what precisely we're looking at. So, if we want to see what a pub sub message really looks like and what our cloud build pub sub message really look like, we're going to run this gcloud pub sub subscriptions pull test sub format JSON command, because then that pretty prints it in JSON. So quickly we can see we have our attributes, we have our build ID, we have our status, and then the data is base64 encoded and looks like gibberish. But honestly, that's good for us at this point, because then we might not get carried away trying to parse it and losing important bits of our data that we decide to leave behind. We want everything in here because it is a magical box full of goodness. Okay, so the next thing ultimately we're going to want is that this data that's right now in PubSub, it needs to get into BigQuery so that we can start building our metrics and we start having our queries and we can start understanding, okay, over the past quarter, over the past year, over the past month, what has our deployment frequency been? And to do that, we are going to, let's clear the screen. To do that, we are going to make a new data set in our project. My project name is called Fun with Metrics, and yours would be called something else. So that's just your project name, your project ID there. And then metrics is the name that we're giving to the data set. So let's go ahead and create this data set. Woohoo, it's created. And now we're going to create a table. So we need to give the whole name here, Fun with Metrics, that's our project name. Metrics, that's our data set name. And then Cloud Builds is going to be the name of our table. And our schema, we're just going to take the entire payload. We know it's JSON, but we're going to just treat it like a string for right now. And we're going to have something called timestamp. And there we go. Cool. And let's just take a quick peek, make sure it's there. Make sure the demo gods smile upon us. Okay, Cloud Builds. There it is, there it is. Payload, timestamp. If we look at details, as we can expect, there are no rows in the table. So how do we get our data from here to here? How do we get it from PubSub and into BigQuery? You have a lot of options. There are some that are, kind of configured more closely with PubSub. If you look at the PubSub UI, it'll have like a little button that says, get this into BigQuery, and I think it uses Dataflow to do that. However, you can use anything really that has an HTTP endpoint, or you have a lot of options. And we're going to talk about two of them. One is Cloud Functions and one is Cloud Run. Cloud Run is really great because you can use any runtime and any language that you want. So if like you are particularly comfortable with the libraries and the language, maybe you want to use Python 2.7. You can't do that in Cloud Functions anymore. But in Cloud Run, since you have a Docker file, you can really make it do anything you want. We're going to use Cloud Functions for this demo, and that's just because we're not going to bother setting up a Docker file and deciding what our runtime is and then creating a push subscription and things like that. We're just going to go directly to Cloud Functions. It's going to go a little bit smoother for this demo. Okay, so we're going to create a Cloud Function. And it's going to be triggered off of PubSub. So let's go ahead and open this up. Cloud Functions is getting ready. Getting ready. Awesome. Okay. So we're going to give this a really great name, BigQuery inserter. And our trigger is going to be Cloud Pub Sub. And our topic is going to be Cloud Builds. And we're going to use Python 3.7. And this very helpfully tries to tell you a little bit about what you're looking for and how to get the data out of your pub sub message. And we're going to use basically, the same kind of configuration here, but we're just going to add a little bit to it. So I'm going to copy and paste over top of this, and whoa, that is a lot of spaces. Okay, it'll still work. Okay, we have import base64, and this is because we need to decode that pub sub data. And we need to import BigQuery, which is important because we need to make sure that we actually have this in our requirements. There we go, Google Cloud BigQuery in our requirements.txt. So then it knows that it needs to install BigQuery. Okay, so every cloud function has an event and a context. We have our pub sub message, and this is exactly the same thing that it auto populates when you go here in the UI. And so we're just decoding the data from our event, and we are using the BigQuery client. Our dataset ID is metrics. Our table ID is cloud builds. Then we get our table ref, and from our table ref we get our table. So once we have our table, we can insert the row, and the row, you'll remember when we created our schema, it was payload, which was a string, and then timestamp. And the timestamp we're going to take from the context.timestamp on data is because it's not always the same. So we need to use, if we're inserting into BigQuery, we need to have something that's going to work every time. And we know that context.timestamp is going to always be there. And so that is a reliable timestamp that we can use. Then we insert rows, and we give it our table ref and the row we're inserting. And this function returns errors. It doesn't break anything if it returns errors. So if you want to make sure that there is an error, a real error raised, you need to explicitly say, hey, if this array of errors is not empty, then raise this exception. Okay. And the final thing we need to do here is we need to make sure that it knows which function we want to execute, and then we're going to create it. And this takes a minute. So let's just go ahead and while we're waiting, look back and reflect on how far we've come and had this short amount of time. So far, we have our cloud builds, and with very little configuration, we have our cloud builds sending all the information that it knows about the event to pub sub at the different stages of the build. And we also have a BigQuery table that is set up to receive this information about these builds. Let's see if it's done. Not done yet. This is, the really fun and exciting part about doing a live demo where you are deploying new functions and containers and things like that. So give you a preview of what we're going to do next is once this is done building, we're just going to trigger the build process over again. Oh, it's done. Excellent. Ooh, green check mark. Cloud build submit config cloud build.yaml. And let's run it. Okay, it started. And so we know, because we saw it with our own eyes, that when this starts, it's already sending a message to pub sub saying, hey, there's this cloud build that is queued, and there's this cloud build that has started to work, which means that if everything is working as expected, we can pop into BigQuery and go look at our little table. Cool. Actually, hey, look, there's some rows there. Awesome. Select star from metrics.cloud builds. And we're going to click show full values. These are like, some big values. Oh, so far we only have working, which is fine. It's done now. So let's see if we have some more rows. Cool, we have a couple more rows. One of them says success. Cool. Okay, so we can see, as I'm just, beating a dead horse here. This has a lot more information. The successful build has a lot more information than the working build. So again, don't try to be clever and drop the data that you don't think you need. You might accidentally, leave things out that you don't know are going to be in there, or you might use keys that don't always exist, and then your code will be upset because you're using keys that don't exist. Okay, let's do something a little bit more useful than a select star. Okay, so pull this out here. Maybe make this a little bigger. Okay, so let's do JSON extract scalar. We're very happy that we saved all our JSON, because now in SQL, we can parse it out and do stuff with it. Payload. And obviously, it's a whole lot easier to edit a SQL script than to try to go back in time and get data from an event that already happened. Oops. It's because I don't have a comma there. Run. And this JSON extract scalar, I think most SQL languages probably have some kind of JSON parsing capabilities now. This is BigQuery, and so this is how this works. And we can see, okay, cool, we have this build ID, we have the different statuses, and we have the timestamps that the pub sub messages were published. But maybe what we want is, we only perhaps, for now that we're starting to play with our data a little bit, maybe we just want a count of our successful statuses. So we're gonna put this into a filter down here in our where statement and write success and run. Okay, great. We're down to one row because we've had one successful build. And now let's see what we can do with it. So, with a couple clicks, I'm already in Data Studio. Let's say maybe we want a nice bar chart that shows the number of successful builds per day. Let's put timestamp down in our dimension. Okay, so we have May 7th, and we show that we have one build today. And let's rename this successful builds. Ta-da! Now we have a chart, and you can pretty easily see that, as time goes on, the same query would, populate out a nice looking chart that looks like this. There's only one tiny problem. When Jez was talking about the 4 key metrics that predict high performance, one of the metrics was not the average number of deploys per day. It was deployment frequency, which is defined as how often does an organization successfully release to production. And this isn't it. This is not the metric. The metric should be something more like this, and our charts should look a little bit more like this. We should be able to say, oh, over the past 3 months, on average, we have been deploying daily. And so how do we get there from this to this? Well, the first thing we need to do is we need to stop counting the actual, number of builds a day. And we need to start counting the distinct days and the distinct weeks that have a successful deployment. And that starts to look a little more complicated in our SQL. I have it open here. So we're gonna use this as a subquery, but we're just gonna add a bit to it. So one of the issues that we had was that this cloud builds table, it only knows information about the days that have had deploys. And so if you look at it, you can say, like, at best it can tell you on the days that we had deploys, we on average deployed X deploys per day. It can't tell you how many weeks, if you deploy weekly, like if you deploy 3 weeks in a month, it doesn't have any information on the missing days. And so we need to get that information. And the way we're going to do that is we're going to generate a date array, and we're going to unnest it so it becomes its own little table. And we're going to look at 3 months ago through today, and it's going to join every day. And we're going to left join to cloud builds. So now we have information about every day over the past 3 months, joined with the days that we know we had builds. And so now we're going to, start doing some interesting stuff. And we're going to truncate the days to the weeks, and we're going to say, like, if there was any day at all, even one day in this week that there was a deploy, we're going to say this week had a deployment. And then we're also going to count the distinct days that had deployments within the week. And the reason why we're going to do that is because systems data is a little bit messy, and there are a lot of decisions that you have to make, and you have to say, like, what does it actually mean to deploy daily? And the definition that I came up with was a daily deployment is 3 or more days in a week that you've deployed. So that's like the majority of the week has had deployments. And right away, we're seeing results that are a lot more useful than this, which is, just the, yay, I had a deployment today. And we're saying, actually, there are a whole lot of zeros in this chart. Even though this isn't, pretty, it's just like this, table. I'm saying, for the past 3 months, most of these weeks have had no deployments. It's not very good, and only today has a deployment. Okay, so how, honestly, if you just wanted to use this is like, worlds better than this bar chart. But if you want something that actually says, hey, you are deploying daily, well, then you just need to, do a few more little complicated case 1 statements at the top here. And these scripts are going to be publicly available soon if you want to look at them and use them and play with them. So I wouldn't worry about precisely what they're doing right now. You're trying to copy them because they will be available soon. And so, okay, so the first thing I'm doing, like I said, is I am counting the days deployed, and I'm saying, what's the median over all the weeks in here of the days deployed where they have over 3 days in the week. And if they have more than 3 days in the week, then we're going to say that you deploy daily. If you have, at least 1 day deployed within the week, we're going to say weekly. Then we're going to check to see if you have at least 1 week that had a deploy in the month. If so, then monthly, else yearly. So let's run this. Yearly. If you remember Jez's chart, yearly is a very poor performance. So let's see what we can do with this data that just pops up and says yearly. This is my fun little hack where I turned this yearly into what looks like a really nice little button. And so we, instead of percentage, we put label here. And let's make this nice and big, yearly. Let's get rid of that. And last but not least, whenever it says yearly, I want it to be red. So when somebody looks at my dashboard, they know this isn't good. Daily is good, daily is green, yearly is red. Okay, so in the past 20 minutes, we're already calculating deployment frequency. How do we get the rest of these metrics? Well, deployment frequency and the builds are actually kind of like the linchpin to all of these metrics. So if you have your build and your deploy data, then you can start calculating lead time. For lead time, you need to know when your commits and your pull requests and things are, like when your changes are, and how long it took from those changes to that deploy. So we have our deploy data. We also need to know change fail. For all of the deploys we did, how many of them caused failures? And that will give us our change failure rate. And we also need to know time to restore. So from the time when we had our failing deploy, how long did it take before we deployed the fix? And that brings me to a little preview of an open source project that I'm working on called 4 Keys. And this is the architecture of it. Essentially, we have a webhook that takes data from all of these different systems. So, we already looked in depth at how you get your deployment frequency. Then we also, might want to have a webhook from like GitHub or GitLab or whatever version control system you use that can give us the timestamps from those changes. And if you're triggering the deploys from a pull request or a push or something, that SHA is actually in that JSON of the build event. And so then you can connect those back, and you can very easily calculate the median time from change to deploy. And similarly, if you're using some kind of incident management system, you would want to put that data in here. So this is a way of collecting all this data, put it through the data, put through PubSub. This pulls out the pertinent information. We use Cloud Functions, but you can use Cloud Run. You can use any kind of compute you want here. And you put it into your BigQuery table, and you create a few different tables, like the Cloud Builds one, or which we call deploys, and incidents and changes. And just from those 3 tables, you can create a dashboard that looks like this. Okay, so quickly, because I think I am coming up against my time here. Considerations are, you want to communicate very clearly to your team what these metrics are for. It's really, I've worked on operational teams and operations teams, and it's really easy to get hung up on a chart. And if you're looking at, this, and this is great because this is almost like an early warning system that, these buttons in the middle here might start saying, oh, now you're down to weekly and now you're down to monthly. But this isn't the thing to concentrate on. It's easy to imagine a team saying, oh, we need to never have this go down to 0. We need to start doing deploys on the weekends. You don't want to do that. You want to be very clear that the point of the metrics is, deploy frequently, but broadly over time. Okay. So the next thing you want to be very clear about is your data definitions. And this is going to be dependent completely on your business requirements. And it's up to you to write down all of your data definitions and your assumptions. So maybe you have these series of deploys, and some of them go to 90% traffic, some of them go to 5% traffic. Do you count every deploy if it has any traffic, or is there a certain threshold that you're cutting it off at? And number 3, more data is better. You never know what's going to change. Your business requirements will change, and you want to be able to go back into your data and just with simple SQL filters, be able to pull out the things that you're newly interested in, rather than trying to go back in time and dig up all the data from logs and like create this like new backfill ingestion system. It's a whole lot easier to just say, okay, we had a where statement before that said where traffic is greater than 90, but now we want where traffic is greater than 80. Much easier. And the last thing is don't optimize for edge cases. Raw data is messy and complicated and full of assumptions, and you will find edge cases. And it's good because it exposes assumptions, which you should then write down and put in your data definitions. But if you're talking about a tiny percentage of your logs, like if, for instance, the timestamp, maybe it's using Greenwich time and you're looking at Pacific time, and then suddenly, because just of the way the days aligned, you're suddenly out of daily deploys, and now you're into weekly deploys. And this is this like one little edge case, and it only affects a very tiny percentage of your logs, maybe. That isn't a thing to like go in and spend a lot of time on. The data, the research that, Dr. Nicole Forsgren and Jez did, it was very broad, and it doesn't do anyone any good to obsess over one data point. So don't optimize for the edge cases. Okay, now we will go to the Q and A, and let's see if there are any of these that for me. Yes, absolutely. I will share this code. How to use this technology to deploy to AWS, either EC2 or EKS. I don't have any AWS experience, but the architecture of this, if you can see it, is the architecture here. It'll be the same basically for any cloud system that you want to use. So you have your events. You need to put them in a table, make sure that they have keys to map together, and then you can start calculating your metrics. Yes. Cloud build and auto. Okay, so maybe I should read the questions out loud. We use cloud build and auto deploy to auto deploy our push. Is it possible to show in a dashboard the active revision number to show to the team the deploy trend? For example, to show how many deploys a day? Yes, that is what we just showed using Data Studio. I think you can use Stackdriver as well, because you can do custom metrics in Stackdriver. You're a little bit more limited on the types of charts that you can make. So you might not be able to make a beautiful little green button that says, hey, you're doing a great job and you are presenting daily, deploying daily, but you can put custom metrics in Stackdriver. I think. In your 4 keys design, what are you planning on using for the data parsers? I am using Cloud Run, and they are essentially they're just little functions. They're very similar to what I just showed in the cloud function. The difference is just that the reason why it's it's a little bit difficult to be able to make just one that then populates everything is because these data types are coming in and from these different sources, and they're just different. And so I like having these microservices that are able to handle this data distinctly. And if this fails, I can make a fix and I can replay these messages, and then I haven't lost any data. And that is a really big and important thing for me. And another nice thing is if you're adding in a new event source, you want to make sure that these ones that we know work still continue to work. So you're adding another service that is completely decoupled. As Jez was talking about the cloud functionalities, being able to push things without breaking other people's code is a really good thing. So these are completely decoupled, and you can add different data parsers for your new source, looking at this new event type that won't affect or break anything else. Okay, let's see if there's any more. I think I answered all of the questions for me. Oh, yeah. Could the automatic audit log from Cloud Build be used instead of creating a functions to BigQuery pipeline? Yes. But then it wouldn't be as easy to get it into a pretty visualization. So if you wanted, a data studio or, Looker or, whatever your dashboarding, dreams are, you're still going to have to somehow get it out of that audit log and make it be something that people can look at and easily ingest and understand, because that's the point of data, is to understand it, not just to have it. Okay, I think those are all the questions for me. Oh, feature flags and deployments. If your change is behind a feature flag, is the deploy when the software is installed or when the feature is exposed to the customers? I love that question, and I will go back to saying clear data definitions. This is dependent on you, your team, your organization, your business requirements. We can't tell you, we don't know how you run your business. So if you consider that is when it's deployed, like if it's running in some way, shape, or form that could break, then maybe you count that. But if it's just, dormant and silent, maybe you don't count it, but it's really up to you. Okay.
Awesome. Thanks so much, Dina, for that amazing presentation. I mean, I definitely learned a ton, and we'll have to put a lot more thought into kind of how I'm kind of creating my own data pipelines for when I'm making, and building any sort of thing. I've been working on a few live streaming projects myself, and pushing those builds definitely has been kind of happening, but just kind of in a void and not necessarily doing it in a very real manner. So I'll definitely be, that was amazingly how fast you connected all these pieces together from literally a project that did not exist. It came into existence on this live stream, folks, and that part is just mind-blowing. And so I saw some people were asking about how we can get their hands on the code and the resources that you're using and the steps and things. And I think you alluded to this 4 keys project, when it goes live, maybe it's already been open sourced, but when that becomes available, I'm sure people will be very keen to get their hands on it. Okay, so it's coming soon, not quite there yet. Yeah, one of the comments on the YouTube live stream side was that it's a little bit hard to find, well, mainly because it doesn't exist right now, but like, 4 keys is pretty generic naming, but hopefully once it's actually released, it will actually be findable. So let's see. I think we don't have any other presenters today. I want to thank everybody for joining, and joining Jez and Dina and myself. Jez or Dina, is there anything either of you want to say to wrap us up? Resources you want to point people to? Any last comments?
No, I kind of just google.com DevOps. Thanks everyone. That was amazing, Dina. Thanks very much for that demo. I know doing live coding demos is super fun, especially with pre-release software. So that was amazing. Thank you.
Awesome. And and be sure to join us. I guess next week we'll be back again and doing back at it again. I'm not 100% sure what the topic will be. Well, that remains to be seen. But yeah, for now we'll wrap it up here. Thank you everybody for coming. Be safe, be well, and we will catch you next time.